the next topic is sizing motors for direct drive fans. All right, so when we think about sizing motors for a belt drive fan, there's a couple things we think about. So brake horsepower of the fan. So we know what the brake horsepower of the fan is for a specific design point. And then what we're thinking about then is what's the nominal horsepower of the motor that I'm going to apply. So if you have a 4.5 brake horsepower fan, a 5 horsepower motor is probably enough. Well, the same is true with a direct drive fan. So I'm again thinking about the brake horsepower of the fan at that design point and what horsepower motor I'm gonna utilize. But the other thing that you have to also consider is fan RPM versus motor RPM. All right, so and this is what I talked about a little bit earlier with sizing motors and wheels, sizing wheels to fit with nominal motor horsepower, nominal motor RPMs. All right, so again, as an example here, I've got a selection that's 20,000 CFM at 4 inches of static. It's a 4-fan array, and the design point puts the fans at a 2,507 fan RPM, and the brake horsepower is 3.6 in each one of those fans. So within our CAPS program, you'll have 2 different selections that you can make. One will be with a 4-pole or 1,800 RPM motor, and in that scenario, we'd have to overspeed the motor, so run the motor at 85 hertz. Okay, and we can do that with a 5 horsepower motor. The other scenario that you can select is going to be a 2-pole motor, 3,600 RPM motor that you would underspeed. So we would run that under 60 hertz. We'd run it at 41, and that would require a 7.5 horsepower motor. Okay, so the reason for that is horsepower is equal to torque times RPM divided by a constant. All right, so I've got an example here. It's a 10 horsepower motor, 4-pole, and what I'm showing you on the graph is that motor running at 60 hertz. So we take that 10 horsepower motor and we run it at 60 hertz. You can see the blue circle is right at the constant torque, constant horsepower intersection. And so we're going to get a full 10 horse at 60 hertz. Now, based on that formula, if we take that same motor and we slow it down to 30 hertz, so we reduce our RPM by roughly half, what you're going to have is horsepower is derated. It's a linear deration in horsepower. So at 30 hertz, we only have 5 horsepower available. Okay, so that's the reason when we underspeed a fan, you have to bump up the horsepower on the motor. Now, conversely, if we take that same 10 horsepower motor and we overspeed it, so we run it up to 90 hertz, now we're on the constant horsepower line, and what you find is that RPM goes up at the same rate that torque comes down, so you end up with that same 10 horse in an overspeed condition. So the moral of the story is you're always better off to overspeed a motor rather than to underspeed the motor.